Okay, in this video we're going to look at strategies and an example for solving bigger systems of linear equations. Some of the main things that we want to look at, we want to make sure that we have as many equations as we have variables. I have 4 variables in this example right here, and I have 4 equations. If I had fewer than 4 equations, there would be no way to get down to just a single variable unless one of those equations was actually, well, no, there would be no way to come up with a unique solution that way. Um, our second strategy, or the second point in the strategy, is to pick a variable that we want to make go away. So I'm going to try to identify and use different colors on these different equations. One of my easily available colors, unfortunately, is black, so we will go with that. And so it doesn't really matter what variable I want to make go away. If I look at my x's here, however, they're all 2's and 1's that are coefficients of those. So I am going to mark x as the thing that I'm going to make go away first. And I'm going to have to make it go away 3 times. And I have to do that by using different combinations of equations. Okay? So one of the easy combinations is I could take the blue and the red equation. So the blue one here is w plus 2x plus y minus 3z is equal to negative 2. And the red one is negative w minus 2x. Sorry. Plus 2y minus 2z is equal to 13. And if I add those 2 equations together, I'll write the answer here in blue. The w's actually cancel as well. That's fine. I get a 3y minus 5z is equal to 11. Okay, so there's one time that I have gotten rid of the x. If I have the green and the black equations together, so if I take my 2w minus x minus 2y plus z equals 6, and the 3w plus x minus 3y plus z equals negative 3, and I add those 2 together, I'm going to get a 5w, the minus x plus x is 0 x's. I've got a minus 5y plus 2z is equal to 3. So there's the x gone twice. One is a combination of the green and the black, one with the blue and the red, and now I'm going to have to get a little bit more creative. If I take my blue equation as it is, so that's my w plus 2x plus y minus 3z equals negative 2, and I double all the numbers in the green equation, I will get a 4w minus 2x minus 4y plus 2z is equal to 12. And if I add those together, I want to get this actually to be a different color than it was before. I'll write this one now in red. So that gives me a 5w minus 3y minus 1z is equal to 10. Okay. I now have 3 equations, and those 3 equations only use 3 variables. I'm going to copy my new equations down here. So I've got a 5w minus 5y plus 2z is equal to 3. I've got a 5w minus 3y minus z is equal to 10. And I have a 3y minus 5z is equal to 11. Okay, let's create a little bit more space here. And I'm going to move these down a little bit farther now. So these are my three equations with just three variables. I can see I've already, in my blue one, there is no w, so if I get rid of the w as a combination of the other ones, because now I'm trying to get down to two equations that only have two variables. So if I take my green equation, 5w minus 5y plus 2z is equal to 3, and I'm going to multiply everything in the red one by -1 and make that a negative 5w plus 3y plus z equals -10. And I'll go ahead and write that as a green equation. That's a -2y plus 3z is equal to -7. And so now I have this blue equation, the 3y minus 5z, and this green equation, and that's two equations and two variables. And this now is sounding very familiar to problems that I've done before. I'm always going to look to see if there's something simplifying that I can do along the way here. There isn't. So I got rid of the w in the last one. I've got rid of the x. I'm going to pick one here. I'll get rid of the y. In order to do that, I'm going to have to multiply this top equation by 2. That will give me a 6y minus 10z equals 22. And if I multiply the bottom equation by 3, I'm going to get a -6y plus 9z is equal to -21. And if I add those two equations together, the y's are going to go away, and I'm going to get a -z is equal to 1. So my z must be -1. And so in my answer along the way here, there's going to be 4 numbers, and my last number is a -1. I probably didn't space those commas out very well. Let's see if that works for me. Okay. Now that I know the z is a -1, I'm going to take that back to one of my other equations here. Maybe I'll take this green one here that said -2y plus 3 times z is -7, and I now know that the z that I'm looking for is a -1. So this tells me -2y minus 3 is equal to -7, so -2y is equal to -4, which must mean that the y is 2. So now I know that my y value here is 2. I know z is -1 and y is 2, and I'm going to go and find one of my equations that had 3 variables in it. Okay. So maybe I'll take this red one. That's right here. It doesn't really matter which one. And that says that 5w minus 3 times whatever y is minus whatever z is equal to 10. I'm going to put that in a space where I have a little more room to work with it. Put that down here. My y, again, was a 2, and my z was a -1. And so this equation becomes 5w minus 6 plus 1 is equal to 10. That's 5w minus 5. That is equal to 10. So 5w is 15. And I know my w is 3. That was this number up here. And now I know 3 of my numbers, so I'll go grab maybe my very top blue equation up there, which said that w, which I now know, plus 2x plus y minus 3z is -2. And my w here was a 3. This was a 2. And my last one, there was a -1 in that spot. So if I work this out, I get 3 plus 2x plus 2 plus 3 is equal to negative 2. So that is 6, 7, 8, 2x plus 8 is equal to negative 2. So 2x is negative 10, and the x is negative 5, and this is the solution. This is the one combination of w, x, y, and z that will make all 4 of those equations true. I would show you how to do this graphically, but the problem is with 4 variables that would take 4 dimensions, and I don't know how to graph in 4 dimensions. But what we have here is 4 four-dimensional planes that are all intersecting, and when they intersect, it ends up being in one 4-dimensional point. Okay, so that process again that we followed here, we use different combinations of 2 equations in step 3 to make the variables go away. Worked our way down until we just had 2 variables or 2 equations, 2 unknowns, found the one variable, and then started what I call back substituting into equations, so that we ended up with equations each time that had only one variable that we could solve for. Okay? So this is the process. As you can see, there are lots and lots of places where if you are not careful, you lose track of a negative sign, you forget to multiply on both sides of an equation or all the things on the equation that you were supposed to. Any one of those little errors and you will not find any of the right values along the way. So you have to be super careful, be organized in your work so that you can go and look back over and see what was it exactly that I did to get here, and did I actually do it correctly in the event that you come up with numbers that don't seem to work. All right.